All right. So today we are going to be covering systems of equations when it applies to word problems. Okay. So what we're going to need to really pay attention to is how we, number one, generate equations based on a word problem. Okay. And obviously we're looking at systems, so we've got two equations, at least two, but all the systems we'll be looking at is two. All right. You guys got four boxes on the front side of your sheet of paper there. We've got three examples, so you will have a fourth box that if you wanted to use for something else, okay, taking extra notes or practicing one of these problems on your own, I highly encourage you to do so. I would take one of the three when we're done, and I would try to solve it all on your own. And as you run into issues, you can glance at the problem, fix the step, and then move on. So I highly encourage that you take one of the three and do that. Otherwise, you guys will see you'll have four practice problems. Actually, yeah, three or four practice problems on the back for you guys to work on. So here we go. All right. So our first problem here, we have the school that Willie goes to is selling tickets, okay, to an annual talent show. And so what we end up having is, and you'll see in ticket situations like this, is that sometimes not everybody is paying the same price, right? And so this is for a talent show where there's a different price in tickets depending on if you're a child or if you're an adult, okay? So, and what we need to understand is that in this case we are going to assume that the adult tickets between the 2 days, you can see on the first day the ticket sales, the school sold 12 adult tickets and 10 child tickets for a total of $274. The school took in $111 on the second day by selling 6 adult tickets and 3 child tickets. What we need to assume, okay, because we're not told otherwise, is that the adult ticket, okay, and the child ticket price did not change between day 1 and day 2. There wasn't a sale on day 1 and then not a sale on day 2. So the price of the ticket's the same. Those tickets, okay, are going to be our variable. All right. So when we look at this, we're going to say A is the cost per adult ticket. And then we're going to use C for child. Okay, cost per child ticket. And you will see as we go through each of these examples, the very first thing we do is we assign the variables. We're not writing any equations. You notice I'm not doing any calculations. These are my two unknowns. You can think of these as X and Y. Okay, but you'll see as we set up these equations that we don't necessarily want to use X and Y because we're not graphing. We don't need to worry about X-axis, Y-axis at this point. We're going to use a method called elimination. You guys will see this, cost per child ticket. All right. All right. Now, when you get to your independent practice, what you guys might want to do, and I highly encourage this. When I say you might want to do, okay, this is parent talk for you will take out your elimination notes. Okay. It's like I'm giving you an option, but I'm not. Okay. For those of you guys that have parents that do this, you know what we're talking about. All right. So let's set up the first one, and the first equation is going to be completely based off day 1. All right. All right. And so we're going to take this information right here. And what it tells me is they bought 12 adult tickets. And remember, A is the cost per adult ticket. So if I take 12 tickets and I multiply it by the price of 1, right, that gives me all the how much money was made in adult tickets. And then I'm going to add that to, you guys see here, 10 child tickets. So 10 child tickets at C dollars, whatever per ticket, right? And they brought in a total of $274. All right. And so you can already imagine what the second equation is going to look like, but if you don't, all right, okay, it's right here. It says that the school took in $111 on day 2, 6 adult tickets and 3 child tickets were sold. Okay, so 6 adult tickets, 6 times how much 1 costs, and then 3 times how much 1 child ticket costs, and they brought in a total of $111. All right, the next thing that I notice is that these equations are set up in the exact same form, okay, which is what we want if we're going to use elimination. These are not set up to graph. These are not set up to substitute. We don't know what A equals or C equals. So we're going to try to eliminate. And it looks like the easiest term to eliminate is A, because I have 12 A's on top, okay, and I have 6 on the bottom. But this is easy to make negative 12, okay? So I need to think to myself, 6 times what is negative 12? And it's negative 2. And so to keep this equivalent, I need to multiply everything by negative 2. All right, so I'm going to recopy the top. Okay, remember, you're taking all of these notes. And then I'm going to multiply everything by negative 2. Negative 2 times 6a, negative 12a. Negative 2 times 3c is negative 6c, or minus 6c. And negative 2 times 111 is negative 222. All right, now we're going to go ahead and add these together. Okay, you can see the 12a plus negative 12c. I wanted opposites, and some of you guys may have been asking, Mr. Olson, we have 12a's on the top. Why don't we just get 12 on the bottom? And we could, right? If I got 12a on the bottom, if I had multiplied by negative 2, positive 2 instead of negative 2, I would have gotten 12a and 12a, and then I could have just subtracted the two equations together. But I highly encourage that you get opposites to add, because less mistakes are made with addition. All right, so you guys will see that's how I will teach it. And so 12a plus negative 12a is 0. So we have 0 a's. That's gone. It's eliminated. And then we got 10c plus negative 6c, which is 4c. 274 plus negative 222. You can see we have more positive, which means when we add, we will end up with a positive outcome, and that is 52. Right? And the very last step is to divide both sides by 4. Okay? And so what you will see when we divide by 4 is that 4 divides into 52 evenly, and we get C equals 13. Now what does this tell me? What C equals 13 means? And this is important, okay, and we've addressed this with word problems. We cannot just leave C equals 13, because that 13 actually represents something in real life, and we need to acknowledge that. If we don't, then there's a deficiency in our knowledge, and you're going to get marked off. Okay, so C equals 13. Well, C is the cost per child ticket. That's $13 per child ticket. Okay, so it's $13, and we use a different color here. So that means the child ticket is $13, right? And then how do we find the cost of an adult ticket? Well, we're going to take this value for C, 13, and we're going to substitute it in. Now, I've got these two equations here. It looks like this bottom one might be the best one. So let's take 13, and plug it in for C here. Okay, and we're going to write this out. So we got 6a plus 3 times 13, because the child ticket is $13, equals 111, right? Well, 3 times 13 is 39. 111, we're going to subtract 39 from both sides, and when we do that, we get 72, and when we divide both sides by 6, we get 12. So what does A equals 12 mean? A equals 12 tells me the cost of an adult ticket. Now, some of you guys might, as you're evaluating this, go, just wait. An adult ticket costs less than a child ticket? Yeah, this is a bad word problem, because typically that is not going to happen. But in this case it did. So what we would say is each child ticket costs $13, each adult ticket costs 12. Okay, so hopefully you guys see how we set up these equations, all right, how they're built, and then how we use elimination, okay, and how we modify that second equation. All right, so now we're on to box 2. We got a plane travels, okay, a plane travels 1,400 miles to Havana, okay, Cuba, and back. The trip there was with the wind. It took 14 hours. The trip back was into the wind. The trip back took 28 hours. What is the speed of the plane in still air? And what it means is still air. It means just how fast was the plane going if it wasn't affected by any type of wind, all right? Now we can agree that if you're going with the wind is helping you, okay, which means it's increasing your speed. And if it's going against you, it's hurting your speed. It's like subtracting speed, all right? Our two unknowns here are R, the speed of the plane. So R is the speed of the plane without any effect by wind. And then we have W, which is the wind speed. Okay. Now this is a distance equals rate times time problem. Okay. Distance is calculated by taking your speed and multiplying it by time. Rate times time. Right? So if you're going 60 miles an hour, that's your speed for 5 hours. 60 times 5 is 300. 300 miles. That's your distance. So if you take the speed and multiply it by the time, you get the distance. All right. In this case, we know on the trip out, right, that the time is 14. Right? The time is 14. The question is what is his speed? Well, we don't know the speed. All right. So we know that it took 14 hours. Rate times time, speed times time. So we take the time and multiply it by the speed. Well, they had with the wind, right? With the wind, which means the wind was helping. So if you take the plane's speed, R, and add the wind, see the wind was helping, so we're adding it. It was actually increasing the plane's speed, right? Okay, and then that will equal the total distance. Okay, so this is on the way out because the wind was helping, all right? Now, on the way back, the wind was hurting. It took 28 hours. So if you took the plane's speed, and since it was going against the wind, like you were subtracting speed, right, from the plane's speed. Now, it's still the same distance. They're traveling the same route. Okay, so here we go. All right, now, we're going to solve this system. Now, instead of distributing this in, what I notice is 14 will divide evenly into 1,400. So let's go ahead and just get rid of that, right? 14 divides into 1,400 100 times, and so we're just left with 100. Okay? And then here, I notice, instead of distributing the 28, let's just divide by 28, because it does divide evenly. We're dividing both sides by 28. And that actually gives us, 50. Okay. All right, and so now we can solve this system. If you notice, they're all in the same form, RW equal sign constant, RW. So we have RW equal sign constant. Do you guys notice right here? Those are opposites. Positive W and negative W are opposites. So let's go ahead and just add these. That'll eliminate the W's, right? Positive W plus negative W gone. What's R plus R? Well, that's 2 R's. And what's 100 plus 50? It's 150. Okay, and then let's divide by 2. And so R is 75. Now, what does it mean R is 75? Well, R is the speed of the plane, so it's telling me that the plane is traveling 75 miles an hour by itself. Okay, so it's traveling 75 miles an hour if there was no wind involved. And if you look at the question, it says, what is the speed of the plane in still air? That means no effect by wind. Well, that's 75. What is the speed of the wind? Well, to find the speed of the wind, W, we need to take this quantity and plug it in. All right. Now, we can plug it into either one of these equations, but remember, see these two equations over here that we were working with? They're equivalent to these. So we actually have 4 options to plug in. All right. So let's take the 75. Let's plug it into the top equation here. All right. So we're going to take this 75 and we're going to plug it in here. And so we get 75 plus W equals 100. Now let's subtract 75 from both sides, and we get 25. Now what does it mean that W is 25? W is 25. It means that the wind speed is 25 miles per hour. Okay? Right. So 75 miles an hour, the plane is moving with no effect by the wind, and it's moving 25 miles an hour. The wind's moving 25 miles an hour by itself. So think about it. If it's going with the wind, the plane's really going 100 miles an hour, right? 75 plus the 25. And then if it's going against it, that means the 25 is being taken away from this plane speed. So that means it's going 50. So with the wind, it's going 100 miles an hour. Against the wind, it's going 50. All right. Okay, last problem. We'll get to number 3. Thank you for being patient, guys, and doing this. So this is so here's another problem, much like we deal with maybe if we were taking 2 separate modes of transportation to the 8th grade field trip. We're not, but we can kind of assume that maybe that could be the case. So we got local amusement park is a popular field trip destination. This year the senior class at high school A and the senior class at high school B both plan trips there. The senior class at high school A rented and filled 10 vans and 4 buses with 320 students. High school B rented and filled 13 vans and 12 buses with 722 students. Each van and each bus carried the same number of students. Find the number of students in each van and in each bus. So they want us to find the number of students in each van and each bus. So I know how many vans and buses they took, and I know how many total students they took, but I don't know how much went on each. And so that is those are going to be our variables. So we're going to use Z for the number of students that went on each, number of students in each van. Okay? And then we're going to use B, let's just use U. So U is going to represent the number of students that went on each bus. Per bus or in each bus. Now I'm not using B because my B's look like 6's, so we're going to stay away from that. Alright, so I assign my variable like I've done in every single example, and you are to do the same, okay, on your examples. Now watch how I come up with this. I'm going to give you a second. I'm going to pause for a second, and I want to see if you can come up with a second equation on your own. So what it first says is the senior class A, so we're talking about senior class A, alright, rented and filled 10 vans and 4 buses, 322 students. So 10 vans. So that means 10 vans with the students, okay, on each van. All right, so 10 per van, right? So we have 10 vans, 10 times V would tell me how many students are in the vans. Plus, we have to add up all the students that went on the bus. Well, you can see here they took 4 buses, and they had an equal amount of students on each bus. So that's 4 times the number on each bus, 4 times U, and that was a total of 320 students. All right, so I'm going to give you a second. Look at high school B and see if you can determine what the equation might be for that. Yeah, so we have, if you noticed here, okay, 13 vans. So that's 13 vans, okay, 13 times the number of students on each van, and then we have 12 times the number of students on each bus, and that equals 722. Okay. So if we're going to find V or U, we're going to use elimination here. You see that we have the same form. These are both in standard form. V's lined up, U's lined up, equal signs, constants. We're going to use elimination. And I think the easiest variable to eliminate is the 4 and the 12 because these are compatible, right? All right. It's easy to make 12 from 4. But we don't want 12, we want negative 12. I want to use addition here. So what do I multiply 4 by to get negative 12? Well, that's negative 3. So we're going to multiply the whole top equation by negative 3. And what we end up with is negative 30V minus 12U equals negative 960. Okay? Remember, we got to multiply all of it, okay, to keep it equal. And then we're going to recopy the bottom equation. All right. All right. And you clearly see here that we have, right, opposites here, U terms, so that when we add them, and that's what we were trying to do, these will go away. What's negative 30 plus 13? Obviously we have more negative, so our answer will be negative in this case when we add. And we will get negative 17v, and that's going to equal negative 960 plus 722. Obviously we have more negative also here, and so we get negative 238. And our last step is going to be to divide by negative 17, and you might be shocked to know that those would actually divide evenly. And so 17 will divide into 238 14 times. Okay, so what does that mean that V equals 14? It means that that's the number of students in each van. So there's 14 students. 14 students, okay, in each van. So how do we figure out how many are in each bus? Well, we can take any one of these equations here, and we can plug in 14 for V and solve. It looks like that we have smaller digits on top. Let's go ahead and take that one. We're going to take 14. We're going to plug it in for V here. And let's do that over here. So we have 10 times 14 plus 4U equals 320. All right. First step, multiply 10 times 14, which is 140. And then we are going to subtract 140 from both sides. And the last step is to divide both sides by 4. And what we end up with is 45. And so what does it mean that W equals 45? W equals 45. Sorry, my variable just like morphed in from a U to a W. I took too much style on my U. Let's go ahead and change that. What does it mean for U to equal 45? And that means that the number of students on each bus, right, the number of students on each bus is 45. So there's 45 students per bus. Okay. So I hope you guys saw how we go about constructing the equations, and then how we use elimination, okay, to find the value of one variable, and then use that information to find the second. Okay. So you guys can practice them on your own. First, I highly encourage you to take one of the three problems we just did, kind of cover it up, do it on your own, all right, and then flip over and finish out those problems. You can see that I started almost all of these problems. I just want you to go in and finish them up. Okay. All right, guys. Have a great rest of your day.